Very good morning. Today we are going to see some problems under Cauchy's integral theorem. Okay, problems are using Cauchy's integral theorem. Okay, Cauchy's integral theorem. Okay, now we know that what is Cauchy's integral theorem says integral C f of z dz will become 0 when f of z is analytic and its derivative f dash of z is continuous at all points inside and on the simple closed curve C. Okay, when those two conditions are satisfied, then we can simply say integral C f of z dz equal to 0. The first problem. Now the first problem is evaluate integral over C z dz divided by z minus 2, where what is this C will be given. So where C is the circle, where C is the circle given by modulus of z equal to 1. Now we are going for solution part. So first we have to write this function in the form of integral C f of z dz. So I am writing it as integral C z by z minus 2 dz implies f of z equal to z by z minus 2. Okay, so we know that only when a function is analytic we can apply a statement. Okay, so this function integral C f of z dz is analytic. I can say it with very high level of confidence. This is analytic because it looks like integral C f of z dz, but there is a point where the analyticity will get failed. That is whenever the function becomes infinity or not defined, that is when a denominator becomes 0, then the function will not be analytic. Okay, so at what point the function will lost its analyticity? At z equal to 2 the function will lost its analyticity. Okay, that is the first thing you have to keep in mind. Okay, so now we have to check whether this z equal to 2 lies inside or lies outside the circle, because we have to evaluate the circle, we have to evaluate the function over the circle. So they have given modulus of z equal to 1. Okay, modulus of z equal to 1 means modulus of x plus iy equal to 1. Modulus of x plus iy equal to 1 means x square plus y square equal to 1, which means x square plus y square equal to 1 square, that is equal to 1. So it can be further written as x minus 0 the whole square plus y minus 0 the whole square equal to 1 square. Okay, why I have written it like this? Because I want to find the center and radius. Now it looks like x minus h the whole square plus y minus k the whole square equal to r square. If so, center will be this h comma k, that is center is 0 comma 0, radius is 1 for this circle. It is just 2 mark. It is not necessary for you to spend this much of time, but you have to understand the problem. That is why I am telling the problem with this much of detail. So now I am going to draw this circle modulus of z equal to 1. How to draw this circle? See, the circle is having circle is having 0 comma 0 as the center and 1 comma 1 as the radius. Okay, now tell me the points. Okay, see here is the center. Where is the center? The center is here, C of 0 comma 0. If radius is 1 means r equal to 1 means it is common everywhere, r equal to 1 and r equal to 1 and r equal to 1, which means the point here is, the point in x-axis is 1 comma 0. The point here is minus 1 comma 0. Okay, here in y-axis also we can write the points like this. Okay, write the points like this. Okay, so x comma y is 0 comma 0, radius is 1. Okay, now we have to check this z equal to 2. This is z plane, this is x and this is y, so this is z plane. Z equal to 2 means it will not lie inside a circle. See, z equal to 1 means if I take z equal to 1 means the real part x equal to 1, there is no imaginary part. Maybe if I suppose it like this, or what are z means 2 equal to 0, so z equal to 2, so x plus iy equal to 2. So then square root of x square plus y square equal to 4 square means x square plus y square equal to see square root of, but I have to take modulus for this, but here there is no modulus, so it is not possible to write all these things. Just we can think z equal to 2 will not lie because the circle is having 1. The circle equation is, see, this circle equation is modulus of z equal to 1. So z equal to 2, if it is 0 here, this is 1 here, z equal to 2 may be somewhere here around the circle. It is somewhere, it will form a loop near the circle. Okay, that is first thing. Okay, so we can easily tell the following points. First point is, okay, f of z is not analytic at which point? Z equal to 2. Second point, oh my god, if it is not analytic, how to evaluate integral over the circle? So there is no worry about it, because fortunately this point z equal to 2 lies outside modulus of z equal to 1. So what I can tell by the second point? f of z is analytic at or analytic everywhere over the curve C. Okay, over the curve C. That is f of z is analytic. So okay, instead of telling this at third point, I am telling this at first point. So what does first point says? F of z is orthogonal z equal to means f of z is analytic everywhere except at z equal to 2. Except at z equal to 2. This is the point of this is the same point what I am telling in first point. Okay, so by third point we can tell f of z is analytic for this C. If it is not over the C and if the C is not modulus of z equal to 1, then it is not possible to integrate this. Okay. Fourth point is f dash of z is continuous at all points inside and on C. Therefore, by Cauchy's integral theorem, integral over C z by z minus 2 dz equal to 0. Okay, that's it. Okay, now I hope you understand the concept, but one thing is, for the examination when the problem is asked for 2 marks, it is not necessary to write the smallest of z into square root of such things and finding center 0,0 radius 1, and then it is not analytic at the point where it becomes 0 in denominator, and fortunately this point is outside the given circle C, so we can solidly say that f of z is analytic everywhere. It is not like that. Simply say the third point, f of z is analytic everywhere over the C, and f dash of z is continuous at all points inside and on C. Therefore interval C f of z dz equal to 0. But one thing you have to ensure, you have to draw the circle and you have to check. If it is 1 means radius is 1. Okay, but you should not have anything associated with the sum of z. Okay, z plus I or z minus I should not be here. Okay, if it is smallest of z means without knowing the center we can tell. Okay, we can write like that, z plus 1 or z plus I. There should be nothing like this. Okay, we shall see some other problem. And by that you can understand easily. Okay.